Okay, so hopefully you've taken the time to review the Normal Probability Plots Explained Open Intro Textbook Supplement video. Now we're going to go ahead and explore an example. The data that you see here and the data that is also located on the guided notes packet that you have is for the National Association of Theater Owners, or NATO. It was compiled with a list of annual average U.S. ticket prices from some years between 1948 and 2019. So just a random selection between those years. So our goal is the following. We want to state the random variable that we're working with. So looking at the source of the information and what type of information you collected, so the individual and the variable might help you define this. After that, we're going to perform our three-step test. So we're going to check the histogram. Does it look like it's roughly normally distributed or bell-shaped? We'll look at the box plot. Do we have at most one outlier, although we would prefer none? And then what does our normal probability plot look like? In other words, does it look like the data is roughly falling along a straight line? So are all of your points, or maybe if you want to say, are all of your ducks in a row? So for part E, we're going to take the results that we have from B, C, and D and make the assumption, is our sample normally distributed? Sorry, I should say, not is our sample normally distributed, is the population that our sample came from normally distributed? Sorry about that error. Okay, so the first thing that we're going to do, we want to state the random variable. So with a random variable, we might call this x, and let's say that this is the average annual U.S. ticket price from a random sample of 50 years between 1948 and 2019. I do see that I want to say ticket prices instead of price. So we're looking at the average annual U.S. ticket prices from a random sample of 50 years between 1948 and 2019. Remember, it's a good idea to go back and proofread your work. So in this instance, I might kind of mention movie ticket instead of just saying ticket. That might be a little bit too broad. Other than that, I think that we've covered all the detail that we need in order to describe the random variable. So let's go ahead and move forward and do our three tests. Make sure that you have your calculator out, and we will jump in and start making a histogram. Okay, so now that we're in our calculator, what I would encourage you to do is make sure that you have your guided notes with you, because you have all the steps for the calculator process listed there. I am going to go through these steps a little bit faster, but remember, you do have all the notes available. So the first thing that we need to do is we need to enter our data. And as before, as we've been doing in chapter 3, for example, we will head to Stat. We're going to select Edit. You can either press 1, or since this is bolded on the 1, you can press Enter. And we're going to enter all of our data in our list. So go ahead and take care of that through the magic of video editing. Mine are just going to magically appear because you don't need to see me entering data for 2 minutes straight. Okay, so all of my data is entered in here. So once we do this, we want to actually create the histogram. So we're going to second y equals, and that's going to open up your stat plot window. I'm going to go ahead and do all of my work in stat plot 1. So since that's already highlighted, I'm going to hit enter to enter the screen. We do want to make sure that the stat plot is turned on, so notice that the cursor is blinking on there, so I'm going to press enter to officially bold it. So now my plot is turned on. And from here, we want to arrow over to the option that looks like a histogram. So I gotta move down first, and then I'm gonna select the third option here that looks like a little bit of a histogram. Okay, so from here, we're then going to go down to XList, and you'll notice that we've got our first option, which is going to be, oh, no, sorry, take that back. I didn't click enter in order to select my options, so now we can see that I have the histogram turned on. So notice that the options had changed below once you selected the histogram. It's basically asking you, okay, where am I pulling the data from? So we want it to pull from list 1 in my case. However, if you have your data entered in a different list, you will want to update that. Don't worry about the frequency, and then if you have an older version of the calculator, you don't have a color available. So now we want to actually see our histogram. For some of you, if you click zoom directly, it will take you to the window. For others, if that doesn't work, if you get an error message, what you would want to do is press second and mode. That will help you quit out of the screen, so then you can go into zoom. So I know that I'm able to go directly into zoom, and I want to select option 9, which is going to be zoom stat. I don't have to actually hover over to the 9. I could have just pressed 9 on my keypad. But when I do this, I get this. So the question now becomes, does this look bell-shaped to you? And my initial response would be, no, not quite. It's definitely not like any of the standard ones that we've seen before, where it's either bell-shaped or uniform or left or right skewed. So for now, we would just kind of have to say, nope, it doesn't look bell-shaped. This doesn't mean that we shouldn't look at the other options, but for now, I would kind of note, this doesn't quite look bell-shaped to me. All right, so let's go ahead and jump into doing the box plot. Okay, so now that we've determined that our histogram does not look bell-shaped, in fact, I would maybe argue it kind of has a bimodal vibe to it if you kind of drew a line over it to like lay on top of your bins. It kind of has a bimodal look to it. Let's go ahead and start taking a look at the box plot. The good news is your instructions on your guided notes take you all the way back to entering the data in, but you've already done that part. So let's just go back into second and y equals. And from here, I am going to go back into plot 1. It's still on, which is great. Now I want to arrow down and select the box plot option that would show outliers if there are any outliers. So I'm going to come over, and it looks like it's the 4th option is the best option. Notice how, I'm going to move my cursor so that it's not blinking on you. Notice how this option, it looks like a box plot, and then there are 2 little dots here. So that's just their little symbol to indicate that this is a box plot that will present outliers. If you had selected this option, this ignores the outlier option. It's just going to draw a box plot from the 5-number summary that would be generated from your data. So again, we would arrow down and make sure that it is pulling from the correct list. Again, all of my data was in L1. Don't worry about the frequency. And then here it's just your choice of what kind of symbol you want to use for your outliers. I would suggest just sticking with the large kind of square here. For example, this is a tiny pixel, so that's not fun to look for with the naked eye. So from here, once you are done, again, I'm going to go into Zoom. And again, if you have a model of calculator that it presents an error message, remember for you, you will want to do second and mode to quit out of the stat plot screen first and then go into Zoom. So we'll go into Zoom. I want option 9. I don't want to click down to it, so I'm just going to press 9. And we can see that we have a box plot already made for us. Super quick. The main thing that we want to note, I don't see any outliers. So that kind of goes in favor, even though we've seen that the histogram is bimodal-ish. So now let's go ahead and take a look at the normal probability plot. As before, you don't need to re-enter all of your data. You can jump straight into the second and y equals function to get back into plot 1. And your normal probability plot, when we come down to type, you're going to want to scroll all the way to the last option. This represents the normal probability plot. If you watched the video, the supplemental video that I shared before, it kind of has that same look to it. So we're going to select this one. And again, it's going to ask you for your list, like what list do you want to pull from? And we want it to pull from list 1. And then arrow down and make sure that X is chosen. This is where all of your data access is going to be located. This is also going to mirror your WAMAP homework questions. Again, I would leave the marks to be these larger squares. It's just easier to see on the screen. Now I'm ready to go ahead and take a look at this. I'm going to do zoom, and again, option 9. And here's my normal probability plot. Taking a look at this, there does seem to be like a little bit of a break, so there's kind of like a twist here. And then there seems to be a slight curve of some of the data near the end. So if you kind of imagine this, or if you have like a straight edge or just a sheet of paper that you could lay on top of your screen and you kind of line it up against your data, I mean, this is kind of trending in a linear fashion, but again, there is this kind of bump or this bend here. And again, I'm kind of seeing here it looks like it's twisting downward, here it's twisting upward. So because of this, if we look at parts B, C, and D, I would note the histogram is bimodal looking. Yes, there are no outliers, but I would also note that there is this kind of bump, and then there's this curvature that's happening. Based off of these 3 tests, I would argue that the data that we have did not come from a normal distribution. Okay, so now that we've gone through that first example, I want you to try one on your own. So the data that you have here comes from a study done in 1910 from the Experimental Error of Field Trials by W.B. Mercer and A.D. Hall. They looked at the wheat yield in bushels, so bushels is going to be your unit of measure, of 500 plots at Rothamsted Experimental Station in Great Britain. So you're going to be looking at a random sample of 43 of those plots. So you're not looking at the full 500. So again, all this information that you have on the slide is already in your guided notes. So you don't have to write all this down. You will want to enter this into your calculator though. So let's jump to the question. So as before, I want you to state the random variable. I want you to draw a histogram using your calculator. Find the number of outliers, if any. Again, using your calculator, you don't have to do any of this by hand. Draw your normal probability plot. And then from those 3 tests, what do you think? Do you think that you have a population that is normally distributed? So to kind of get us started, again, for our random variable, we would have x is equal to, I would say, like the wheat yield. Sorry, that's a weird looking E. In bushels, so let's include the unit of measure, otherwise it's really not clear, of 43 out of 500 plots at Rothamsted Sorry, that's better. Rothamsted Experimental Station. In Great Britain. As I've mentioned in class, or at least I hope I've mentioned in class, sometimes your first take of defining the random variable it might need some editing. So in this instance, I'm going to call myself out here and kind of say, um, instead of saying 43 out of 500 plots, I would say 43 out of 500 randomly selected. I think that that's an important detail. Remember how all the way back in chapter 1 we had mentioned this idea that we want to make sure that our sample is randomly selected. So this way it kind of hopefully eliminates maybe some of that potential concern of bias, like you didn't go through and you only selected the plots that yielded the largest amounts of bushels or something like that. So now that we have this definition of a random variable, go ahead and jump into your calculator, take some time, work on this. I'm going to have a more condensed solution, but I will go over these results with you with the calculator. So take some time, pause the video, give it a try, and then from there, when we're done, if you have any additional questions, remember that you can email or go to a tutor for additional support. I do want to make sure that you do feel comfortable with this concept. All right, so pause the video, give it a go, and then once you press play, we will review. Okay, so now we're going to investigate the solution to our bushel problem. So I've entered in all 43 of my data points. And remember, again, I'm going to go to second and y equals. My plot is already on. I'm doing all my work in StatPlot1. So I'm going to enter into there. It's already turned on, and I'm going to take a look at the histogram first. So that's my third option. I, again, had all my data in list 1, so I'm going to leave that as L1. Leave the frequency. I think blue is pretty visible for the video, so I'm not going to change that. And then because of my calculator, I don't have to quit out of the screen, so I'm going to go into Zoom and select option 9. And I mean, taking a look at this, it's getting there. It's a little bit high over here on the left, but again, if we had maybe had more data, if we had taken a larger sample, perhaps our data would look a little bit more bell-shaped. But I'm kind of saying with the 43 data points, we've got that's pretty close to symmetric here. It's kind of a nice bell shape. I'm going to stop talking about that. I think I've really driven that point home. So at this point, let's go ahead and jump back and take a look at our box plot and see if we have any outliers in the situation. So again, second, y equals, gonna go back into plot 1, arrow down to type, and I want the fourth option, so it looks like the box plot with 2 little dots on the right. This is their symbol for this one will tell you if you have outliers in your box plot or not. So I'm going to remember to select that, so it's bolded. I still want it to pull from list 1, still a frequency of 1. We're not doing a frequency table. And then I'm going to leave the mark as like the bigger boxes so I can see it better because I'm old or something. You know you all know that I wear glasses, so I need all the help I can get. So from here, I'm going to go to Zoom, and I'm going to select option 9. And once again, this is good news because I have no outliers. If I had outliers, I would see those little square boxes appearing either on the left or the right. And again, if you're like, what if they're off screen? When you're doing a Zoom stat, it's taking all of that information into account, so you don't have the risk of like an outliers there, but it happened off screen. You've got everything logged in, so you're safe. Lastly, we'll go into, again, second and y equals, and take a look at our normal probability plot. I'm going to go back into StatPlot1, it's on, and then I'm going to select the 6th option, or the last option. Kind of looks like a little bit of a weird staircase or almost a straight line. It's very pixelated though. Going to select that. Yes, I want it to pull from L1. Yes, I want my data axis to be on the x-axis. It really doesn't matter ultimately, but for the sake of consistency, your data axes will appear on the x-axis in your homework. So just to kind of get you into the groove of it, we're going to keep it consistent. I still want my marks to be the larger squares and my color blue. From here, we'll go to Zoom and option 9 for Zoom Stat. And again, this looks a little bit better than what we had in the movie ticket example. Yes, there is a little bit of a bump, but it's not as pronounced. Again, if you took a straight edge or like a note card or a sheet of paper and were to lay it alongside these dots, you would kind of note they're all kind of fallen in a straight line here, with the exception of this overachiever over here. But again, I'm not really too worried about it, plus the fact that we don't have outliers, plus the fact that we have a histogram that is approaching a bell shape. I would say, based on all of these observations, I'd assume that our population is normally distributed here. All right, this concludes our examples for this lesson. I would encourage you to try some of the practice problems in the back of the book because you have access to the solution manual. If you have any questions, please let me know. Thank you so much.